All right, so let's go ahead and take a look at solving these systems of equations algebraically. And so I'm going to do substitution as a method. I'm going to do elimination. I only use substitution in one situation. And when we look at the problem set, I will show you. Essentially, when I have stuff like this where it looks like one of the variables isn't isolated, you know, like none of these variables are isolated, I would always use elimination. Same thing here. None of the variables are isolated in any of these questions. So I would have used elimination. It's only something, and I'll show you in the problem set here. It's only something that where I can isolate the y, right? Like y is isolated. Or it could have been like something like this where the x is also, you know, very close to being isolated. That I would have used substitution because one of the variables was already like solved for. If one of the variables isn't solved for, I would use elimination every single time. Okay, and so we'll talk about elimination. So when I do these practice ones here, let's just pretend that one of the equations was already solved. Like, let's just pretend this equation was y is equal to 2x here. And let's pretend that this equation was y is equal to let's see, add y, add 2, so x plus 2, for example. Okay, so let's just pretend that that was, you know, the situation. Also, like this one here, let's pretend that this was y is equal to x minus 5. Okay, so let's just pretend for these. Okay, so now I'm going to take my 2x and I'm going to plug it in for my y here. So I have x plus 2x is equal to 3. So 3x is equal to 3. Divide both sides by 3 and I get x is equal to 1. I take one of the equations, either the top one or the bottom one, and I plug the value of x in to solve for y. So y is equal to 2 times 1, so y is equal to 2. And I write this as a coordinate point, not just as x and y equals. Okay, so now I'm going to take this x plus 2, and where I see my y, I'm going to plug in x plus 2. So I have x minus 3 times x plus 2 is equal to negative 14. So x minus 3x minus 6 is equal to negative, oh my goodness, negative 14. So negative 4x minus 6 is equal to negative 14. Add 6 to both sides, so negative 4x is equal to negative 8. So x is equal to 2. Wait, nope, just kidding. X minus 3x is a 2x. So my x is equal to 4. I apologize. This is a negative 2x. X minus 3x is a negative 2x. Okay, so now I'm going to plug in 4 into, I'll just do it the bottom equation. Y is equal to 4 plus 2. So y is equal to 6. So my coordinate point is 4, 6. Okay, so now here, x minus 5 goes into my y, so 2x minus 2 times x minus 5 is equal to 10. So 2x minus 2x plus 10 is equal to 10, and I get 10 is equal to 10, so this is infinitely, oops, I cannot spell, many solutions. Okay. All right, so moving right along here, we will move into elimination. I'm not going to do any more substitution. Okay, so elimination. And when you do elimination, you're looking vertically how you can cancel things out. So if I look here, if I multiply the second equation by negative 1, I would get 3x plus y is equal to 3, and then I get a 3x minus y is equal to negative 3. So essentially I would get 6x is equal to 0, so x is equal to 0. Now when I plug in x equals 0, so 3 times 0 plus y is equal to 3, so y is 3. So my coordinate point is 0, 3. Okay. Here again, if I multiplied everybody here by a -1, my x's would cancel out. So I have 6x minus 3y is equal to -14. Negative 6x plus y is equal to 2. So then I get -2y is equal to -12. So y is equal to 6. So if y is equal to 6, so 6x minus 3 times 6 is equal to -14. So 6x minus 18 is equal to -14. So 6x is equal to 4. So x is equal to 2/3. So then it's 2/3, 6. Okay, so that's elimination. Again, here, elimination can get a little tricky. I can multiply one of the equations by something, or I might have to multiply both equations by something. Like if I was here, to cancel out the x's, I'd have to multiply everybody by a 3 in the top and a 2 in the bottom. Here, I can just multiply everybody by 2 in the top, and I would get my x's to cancel out. So I have 2x minus 6y is equal to -6, and -2x plus 7y is equal to 10. So y is equal to 4. So x minus 3 times 4 is equal to -3. So x minus 12 is equal to -3. So x is 9. So 9, 4 is my solution. Here, so -6x minus 18y is equal to 0. 6x plus 22y is equal to 8. Those x's cancel out. 22 minus 18 is equal to 4. So 4y is equal to 8. So y is equal to 2. Okay. So if y is equal to 2, so -2x minus 6 times 2 is equal to 0. So -2x minus 12 is equal to 0. -2x is equal to 12, so x is equal to -6. So -6, 2 is my answer. Okay? Alright, so now it's time for you guys to try some problems on your own. You can use elimination or substitution, but I will say this. I would say quite often you will use elimination more than you'll use substitution. So let's look at 3. Let's look at 4. And let's look at 8. And let's look at 10. And you can get fractions. So, I mean, most of these that I'm picking right now, what did I say, 8 and 10? Most of what I'm picking right now hasn't had a whole lot of fraction work in there. They've been working out real nice and easy. But in the end, when you guys do systems of equations, they can have fractions in them. And so I do want you guys, that they are fractions, to leave them as improper fractions, no mixed numbers, and no decimals. Okay? So it is your chance to try some on your own. 3, 4, 8, and 10. And then we'll come back and look at them. Alright, so we're back. 3 is pretty easy, straightforward. The x's cancel out, so I have 5y is equal to 0. So y is equal to 0. So x plus 3 times 0 is equal to 4. So x is equal to 4. So 4, 0 is my solution. And I used elimination because it was easier, because I look vertically and things cancel out. So here, this gives me 4y, oh my goodness, my handwriting is terrible right now, is equal to -8. So y is equal to -2. So 2x plus 3 times -2 is equal to -12. So 2x minus 6 is equal to -12. 2x is equal to -6. So x is equal to -3. So -3, -2 is my solution. Okay? So now I might have to multiply one or both of the equations by a number. And I'm going to go ahead and let's eliminate y, because one of them's positive and one of them's negative. So I'm going to multiply both sides by 2. So I get 2x plus 6y is equal to 8. 2x minus 6y is equal to 8. So 4x is equal to 16. So x is equal to 4. So then x plus 3y is equal to 4. So x plus 3 times 4 is equal to 4. So x plus 12 is equal to 4. So x is equal to negative 8. So negative 8 comma 4 is my solution. Oh, I plugged it in the wrong spot. I'm sorry. I just noticed that. X is equal to 4. So in my x plus 3y is equal to 4, I'm plugging in 4 in for my x, not for my y. I don't know what I was thinking. I'm solving for y. Oh my goodness. Okay, so then I subtract 4 from both sides, so 3y is equal to 0, so y is equal to 0. So my coordinate point is 4 comma 0. Don't get confused. When I did this here, I accidentally plugged in 4 in for y, not in for x. It's getting late when I'm trying to record these videos, so I apologize. It is well past Mrs. Hayden's bedtime. Okay, now for this one I'm going to use substitution because one of the variables is already isolated. So I'm going to plug in 3x minus 5 into this. So I have 3x minus 3x minus 5 is equal to negative 1. So 3x minus 3x plus 5 is equal to negative 1. So I get 5 is equal to negative 1, which is not true. So this is no solution. Okay, and that is it for solving systems of equations.